The Antique Wireless Association was formed in 1952. It's maintained a museum for many years, first in a location west of Rochester, New York. Then in 1958, this barn in the small town of Holcomb, New York, became the AWA Museum. This remained the museum until 1975, at which time the AWA moved into the nearby Bloomfield Academy building. The barn is still part of the total museum. It is here that we keep the surplus equipment and also use it as a depository for equipment we move for exchange purposes into the new museum. Every year we take certain things out of the new museum, store them here in the barn, and move other items into the museum. In this way we always have something new to show. This barn, by the way, houses the 7,000 tube collection. It also houses certain military and classic receivers. In 1975, the AWA opened its new museum in this building, which at one time was the Bloomfield Academy, a building erected in 1837. This former school building is now owned by the Bloomfield Historical Society of East Bloomfield, New York. The Antique Wireless Association shares the upper floors of the building. As one ascends the stairs in the building, the first view will be that of this picture, which is titled The Golden Age of Entertainment. This is a very popular area because it brings together the pieces of equipment and things one sees in everyday life. Here one sees old phonographs, early television sets, and early radios, all of which have meaning to more people than older equipment, which we shall see later. Of interest to the far right is one of the very first broadcast transmitters still left intact. It was used at WTAG in Worcester, Massachusetts, and is dated about 1922. This 1922 Western Electric broadcast transmitter is all original equipment. Then there are the many old phonographs, some dating back to the turn of the century. The old Edison type with the cylinder records. Of great interest are the early television sets. And one can see at the lower left a 1929 Jenkins Nipco disc scanning type set. This has the revolving disc with holes in it. It was made in 1929 and was a commercially made receiver. It's in excellent condition and has a rather complex series of mirrors and lenses to make the picture. And right next to this television receiver is a color television scanner. This was a competitor to the RCA electrical color scanning system. It has a revolving disc with the 3 primary colors. And by the way, it's operational. Right behind the scanning disc is a Deforest radiophone, one of the very first broadcast transmitters made. It was made in 1920 by the Deforest Company, and one very similar was used at the pioneer station WWJ, which challenged KDKA. Now, as we move around the room, this next slide presents some showcases. There are many, many exhibits in this room, and one can spend many hours viewing them. However, let us dwell on one or two here. The showcase at the right is full of early Morse telegraph equipment, some of it dating back to 1850. We have a key which we believe belonged to Joseph Henry. It came from Princeton University. We have many early telegraph keys, relays, sounders, and stock tickers, all used on landline equipment. In this showcase, there are very early submarine cable keys and unusual types of landline instruments. The center showcase is one of the collectors. And here you can see the early Atwater Kent breadboard radio receivers, which are choice items for the collector. In the case at the left, one can see early electrical measuring equipment, very old and peculiar-looking meters, some of them dating back to the Civil War. There's much interest in these measuring instruments. Let us take a look now into the showcase in the center of the room. This case houses some of our very early commercial equipment. The lower shelf contains equipment that one would have found on board the Titanic when it sank in 1912. Starting at the left of the lower shelf is a Marconi magnetic detector of about 1910 vintage. Next to it, with the several white cards, is a 1907 multiple tuner made by the British Marconi Company. We believe it's one of the rarest pieces of Marconi equipment in North America. The multiple tuner and the magnetic detector make up the necessary pieces for a receiver of the Titanic period. To the right of the tuner is the famous Marconi 10-inch spark coil. In the middle of it are the two gaps. This coil was used on board ship over a period of about 30 years, from the turn of the century up to about 1930. In the later years, it was used as an auxiliary or emergency transmitter. The coil is a vibrator type with the vibrator on the end. Using 30 volts DC, it would run almost 500 watts. The piece of equipment at the far lower right is a British Marconi detector unit. With this, you have a choice of 4 mineral detectors or a Fleming valve. The Fleming valve can be seen. It is the vertical tube next to the side. On the top shelf at the right is a 1905 Marconi coherer, which is very rare. And to the left of it, on the top shelf with a card, is a replica of Marconi's coherer receiver like he used to demonstrate wireless to the Queen of Elizabeth in 1898. And at the far left, not seen too well, is a 1905 Telefunken coherer receiver. Here we're looking at another showcase which is full of tubes. Altogether, the association has approximately 7,000 tubes. We have quite a few in this display, and the most unique and rarest is in the bottom center of the showcase, a 1905 Fleming valve. We believe it's one of the oldest radio tubes in America. Keep in mind now that the Fleming valve preceded the Deforest Audion, and this particular tube of 1905 was made 1 year after the discovery of the valve by Fleming. It was given to the association by the British Marconi Company of England. Note the shelf of tubes above the case. This next slide shows a close-up of a few of them. Obviously, we can't show all 7,000 tubes, so we selected groups of them for display. This is a group of RCA transmitting tubes of the 800 series. Every tube number begins with 8, followed by 2 digits. We display an 800 going right up to 899, a water-cooled tube rated at 100,000 watts. A very early commercial receiver is shown in this picture. It was used on board a ship, let's say about 1912, 1913. It's a very rare receiver made by Wireless Apparatus Company. The next slide shows another very early receiver. Note all the dials and knobs on it. This was made by the Canadian Marconi Company about 1914. It's a crystal set, I might add, and was used for transatlantic work. This is an exact replica of Major Armstrong's original regenerative receiver, which he made in 1912. He is credited with inventing or discovering regeneration. This replica, however, was made in 1922. His whole life was one of patent litigation and lawsuits. In 1922, he was asked to make an exact replica of what he had made in 1912. This receiver is the one he actually made personally in 1922 to bring into court. And this is what the first regenerative receiver looked like. On top is the Deforest Audion tube, which it used. As we move around the room, we go into the library and see a vast collection of early radio keys. And here we have all kinds of keys used by the radio operator, both the ham and the commercial operator. There are little side swipers, all kinds of automatic, semi-automatic bugs, and huge keys used on board ships. One of these large keys, by the way, weighs 12 pounds. It's a very fine collection of early keys. As we leave the little library, we approach the other room on the floor, and we are looking into the store. On your right, you can see an orange section. Let us closer, and you can see that on this board are many phonograph records. One can actually see the development of the phonograph record starting with Edison's first cylinder. It was a Hill and Dale vertical cut record dated back to the turn of the century. And then you see the very first of the flat disc records. One of them is dated 1905, and the others progressively through the years right up into the 1930s. In the upper right is a large electrical transcription record used in a broadcast station. Also on display are many different types of pickups that were used in early broadcast work. Now we enter the room and are in the 1925 store. If one went into a store back in 1925, this is what you'd see. There are stocks of receivers of the period on the shelves. The showcases are full of 1925 vintage parts, and there's a stock of radio tubes. You are in the store of 1925. I might add that in this store, we have several old receivers operating so you can hear music of the past. It's a very entertaining place, particularly for the collector. Adjacent to the store, we have another section of early telegraph equipment. We have dozens and dozens of early relays, sounders, and telegraph equipment used at the turn of the century. Note the clock. This is a Western Union clock that came out of the Rochester Western Union office, and I believe it was installed before World War I. In this same section, you can see primary cells and early recording devices such as Morse registers and so on. And I might add that a lot of this telegraph equipment is operational. One can actually operate the key or bug and hear the sounders click. Moving a little further into the room, we are in what we call the commercial section. We're looking at an installation of what would have been on board a ship in 1920 right after the First World War, possibly during that war. We have two 1,000-watt quenched gap spark transmitters. That's right, 1,000-watt commercial spark transmitters of World War I vintage, and of the quenched gap type. One of them, by the way, is a Marconi transmitter. In between the transmitters, you can see the receiving equipment. There are Marconi and wireless specialty apparatus receivers of the commercial type. Of course, equipment of this type is of great value to the collector. These sets are selling for $500 to $600 apiece. There were not too many of these sets made. We're looking at the 1,000-watt quenched gap Marconi spark transmitter. This, by the way, was given to the association by the United States Coast Guard. At the end of this room, you can see early broadcast equipment. The large black rack transmitter at the left came from W2XR. W2XR preceded WQXR, the New York Times station in New York City. It was a high-fidelity station and pioneered in hi-fi broadcasts. This is the original transmitter, which the association obtained from the owner's son in Long Island. On the shelf, one sees early microphones of the 1920s up through the 30s, all kinds. Single button, double button, condenser, ribbon, other types of mics used in broadcast work. In addition, there are the early monitoring receivers made by Western Electric, which are quite rare. All of the early broadcast stations had to monitor 600 meters, the SOS band, and Western Electric made those receivers. Now, leaving this room, we will go up to the third floor, and here we are. We're looking at a modern amateur radio station of about 1917 vintage, or immediately after the war in 1920. At the left, with the big coil, is a 1,000-watt synchronous rotary spark transmitter. It's the original. It was not made up in recent years, but was taken off the air in 1922. It was made by the first president of the Antique Wireless Association, George Batterson, whose call used to be 8TC. This is the 1 kilowatt sync rotary spark transmitter he used back there in 1921 and 22. A little closer look at the receiving section shows the equipment you would find in the station in 1920 and 21. At the right is a Reinhardt's receiver, and at the left, with the torn speaker on top, I misspoke. I don't mean torn, of course. It's a horn speaker, and it's not torn. That is an early Greeby receiver, both contemporary of the early 20s. And note the green board in the center of the picture with the open wiring. That is open cleat wiring, typical of the wiring used in 1916 through 1923. This was installed to show visitors what wiring really looked like in some of these early stations. The next picture is the 1,000-watt sync rotary spark set. One cannot see the lower section too well, but in it is the huge spark transformer and the oil condenser. The glass condenser plates are immersed in oil. On top is the rotary gap, a huge oscillation transformer. We use this transmitter for demonstration purposes occasionally, only for a very few moments. It's quite deafening, making a lot of noise, and of course it does cause some interference, so naturally its operation is minimized. It is interesting to see this kilowatt rock crusher in operation and to watch as one throws it in and out of sync as the 60 cycle voltage with 120 peaks comes into sync. The next picture is quite dark, but if you look in the center you can see some sparks. This is an actual picture of the rotary gap of this 1 kW sync rotary spark transmitter in operation. It's an interesting sight, but rather difficult to photograph. In another corner of the room, we see an amateur station of about 1922 or 1923. In the background are all the Qsl cards of the 1920s. Qsl cards became popular about 1922, and from that time on, of course, the amateurs exchanged cards. These cards don't have a W on their calls, as they did not start to use the W until 1927. For a short time before 1924, they used U before the call letters, then NU, and finally, as a result of international regulations, W became part of the call. At the right of this picture, you can see the receiving equipment. There are a couple of Greeby receivers. There's a Zenith and the Chicago Radiolab CRL, which was a popular receiver at the times, developed by 9ZN R.H.G. Matthews. In addition, there's another Reinhardt's tuner. On the upper deck is a Deforest interpanel receiver. All this equipment is usable. This station, 2AN, actually has been on the air. When it is, of course, we have to operate on 160 meters because in 1922 the amateur was not operating on 80 or 40. Those wavelengths were strictly for experimental work. Most operations, particularly in 1921, was still on 200 meters. This station was made and set up for operation on 200 meters, so to make it operational today, we merely tapped down on the coils and ended up on 160. This is a close-up of the transmitter 2AN. Of course, when we're on the air, we use W2AN. The transmitter is on the upper shelf. It's authentic. Every part of the transmitter is 1922 vintage. And starting at the left of the transmitter, the circuit is a UV202 Hartley oscillator. That drives the UV202 buffer stage, which in turn drives the UV203 final amplifier. The audio section is at the right. A single button carbon mic is used with a UV201 speech amplifier driving another UV202 to drive a UV203 Heising modulator. We obtain possibly 20 or 30% modulation at best, but it does modulate the signal, and on occasions we operate on phone on 160. At the bottom of the picture are some jars with whitish material in them. Many visitors think they're batteries, but they're not. They're chemical rectifiers. In the early days, stations either used raw AC on the plate or they used some type of self-rectification. But the better stations used batteries, motor generators, or chemical rectifiers. We selected chemical rectifiers. They are rather spectacular. They consist of lead and aluminum plates in jars, and the chemical is just plain baking soda. Now, not seen in this picture, but at the left are many other operational spark transmitters. There are spark coils, the Ford spark coil type with a vibrator. We have a 1912 transmitter using an electrolytic interrupter and spark coil, and we also have a non-sync rotary spark transmitter. Altogether, there are 4 different types of spark transmitters in operation, in addition to the W2AN tube transmitter, which you see here. Following are pictures of some very interesting pieces of equipment and our most recent displays. Here we're looking at a very early and very rare Deforest radiophone made in 1920. It's one of the very first commercial radiophone transmitters available and was frequently used in broadcast stations. A similar model was used at WWJ. They and KDKA both claim to be the first broadcast stations. This is the exact model made by Deforest and used at WWJ in 1920 when they first went on the air. It uses a modulated oscillator. Among the more popular items in the museum is this large phonograph with a large horn. This type of phonograph was actually used in radio stations. In the early days, you did not have electrical pickup from the record. This was a mechanical phonograph with a crank to wind it up. There was no electrical way to get the music off the record, so in order to use it for radio, you placed an ordinary telephone microphone in front of the horn, wound up the motor, and put the mechanical reproducer on the record. The microphone would pick up the music from the horn and feed it into the radio transmitter. This is certainly a very crude arrangement. The little television set at the left on the lower shelf is really a 3-inch set made by Pilot in 1947. That's right, a 3-inch set. Even though the tube is only 3 inches in size, the picture looks larger because there is a magnifying glass in front of the picture tube. It was common in those days to sell a magnifying glass to put in front of the tube to make the picture look larger. Here we're looking at an extremely early television set. This was made by the Jenkins Company, and as you see, the screen on this television set is fairly good size, maybe 7 inches. But really the picture is not 7 inches at all. The next picture will tell you why. This is a side view of the same receiver. You see, there's a large round disc with 48 holes in it, and each hole has a magnifying glass in the hole. These holes are not in a uniform circle around the disc. They're in the form of a spiral, and the major to minor diameter of the spiral is 1 inch. Now what we do is to scan a picture with a spiral, so the size of the picture to be seen is the major minor diameter of the spiral, which is 1 inch. Light comes from the neon lamp, which is to the left, and goes through the lenses and is magnified. It then goes up and hits the mirror, which you can see at the right. The light is then reflected to the ground glass in the front of the set. So the little 1-inch picture at the spiral ends up being approximately 7 inches in size. This method is very crude since there were only 48 holes, and this gave only 48 lines to the picture, so it didn't have very much resolution and the picture was not very distinct. The modern television set has 525 lines. This is a view of another one of those spinning discs used in television. This disc is a large one with a spiral having a major minor diameter better than 2 inches. Again, you have lenses in the spiral. This disc belonged to Dr. Alexanderson of General Electric Company. Here is an example of early color television. Again, they used a rotating disc with the 3 primary colors rotating in front of an ordinary black and white receiver. If you synchronize the speed of the disc through the circuit inside the set, you can obtain very nice color television. However, a mechanical color television was not practical. It was large, it was noisy, and limited in scope. The Federal Communications Commission adopted the present-day RCA electronic color system instead of the CBS color scanner. Now we're looking at a showcase of very early loose couplers. Loose couplers are forms of coils used for tuning in radio stations. In the upper right, you see a vertical loose coupler made by Radio Apparatus Company. This is a very rare coupler made about 1914. One coil goes up and down by using a weight and pulley. It has many, many turns, as does the other loose coupler in the center top of the showcase. That was made by F.B. Chambers Company in Philadelphia. Note the hundreds of turns, so it could tune to several thousand meters. In those days, the thought was that the longer the wavelength used, the greater the distance covered. So they made these couplers to tune those long, long wavelengths. Immediately to the left of the big coupler, you see a little loose coupler with some tap switches. This is the Clap Easton loose coupler, made about 1915, and was the personal property of Major Armstrong. Major Armstrong used this coupler when he was a young man, and it came from his estate. Inside the showcase are many couplers and coils, most of which were made before World War I. This is a general view of the Armstrong room looking east. The large painting on the wall is a view of the Lawrenceville, New Jersey AT&T transoceanic station. From this station, they had telephone circuits all over the world. The painting was made in 1928 when the station was built, and it shows some of the famous Sturba array beam antennas. Below the picture, you see some of the tubes in the AWA Museum. Altogether, the museum has some 7,000 tubes, and this is just a small display of part of them, as indicated in an earlier picture. This is a telegraphone. It's the first commercially made wire recorder of about 1908 or 1910, and was invented by Polson of the Polson arc fame. The recorder uses no tubes, but operates with induction coils, and one talks into a diaphragm like the early telephones. It was marketed to compete with Edison's dictaphone, which used the wax cylinder. Of course, it's the forerunner of the modern wire and tape recorders. Here we're looking at the magnetic detector in the showcase, which we mentioned several pictures back. This was one of the first practical detectors used in commercial operation. At the far left, you can see a handle. This would wind a clockwork motor, which would keep the iron wire belt moving. This detector worked somewhat on the principle of the iron wire recorder, magnetizing and demagnetizing the wire. You can see the magnets hanging down. This is a very rare piece of equipment, and was used by the Marconi company as a detector for many years. This showcase is one full of early crystal sets. Most of them were made before World War I, though some are post-war. There are Deforest crystal sets, Colby tuners, and other early crystal sets. Ones of special interest are at the far right with cards on top. One is a Radiola 1, which is very rare crystal set of 1921. Next is a wireless specially apparatus radiola, which is extremely rare and is highly prized by the collector today. All crystal sets of this period are, I might add. This is our solid state display. We show the progress made in the development of present-day state-of-the-art, and we start with a simple crystal detector in the upper left. Then we see a diode, half-wave rectifiers, which are solid state. Then we see the first transistor type, and you can see the point contact, early transistors developed by Western Electric and General Electric. Then you see other transistors. There are chips, integrated circuits, and in the lower right is the ultimate with the combination of chips and printed circuits, which literally have thousands of transistors and diodes in a very, very small area. This is our latest display case, where you see both television receiving tubes and transmitting tubes used in the cameras. In the lower part are pre-war television picture tubes and early cathode ray tubes. On the top shelf are the early camera tubes. Here is a view that is not too good of the early camera tubes. We're told we have the largest collection of camera tubes in the world, showing their development. These were all obtained from the RCA Research Laboratory, where the tubes were developed by Vladimir Zworykin. First, there is his earliest tube, which is 40 to 45 years old, the original iconoscope. You see the iconoscope, the image iconoscope, the orthicon, the isocon, the image orthicon, and at the far right, the modern television tubes like the Vidicon and Plumicon. There's one tube, however, that was not developed by RCA. It's the Farnsworth dissector tube, which is also a very early tube contemporary with the iconoscope developed by Zworykin. It is a very, very, very rare tube. You are looking at what you might say is the ultimate in a tuned radio frequency receiver. This set was made about 1928, and it used the first screen grid tubes. This came as a kit and was known as the Sergeant Raymond. It uses 4 states of tuned RF and a detector, a tuned detector. I'll repeat that. It uses 4 stages of tuned RF and a tuned detector. So you have 5 variable condensers in this set. The detector is a 201A, and the output tube is a 112A. This was the ultimate in tuned RF sets before the AC and superhets became popular. This display of early headsets is on the 3rd floor of our museum. There are 51 different pairs of headphones here. Some of them are from foreign countries such as Germany, France, Italy, England, and even Japan. All of these headsets were made before 1930, and many of them are dated before World War I. We sincerely hope you've enjoyed our little trip through the Antique Wireless Association Museum. Please accept our cordial invitation to visit our museum in East Bloomfield whenever you are in the Rochester, New York area.